All right, so let's go over the review here real quick. Some of these you ought to know. Avogadro's number, that's the mole, 6.02 times 10 to the 23rd. And that can be a mole of anything, just depends on what you're talking about, right? So speaking of which, I mean, we could have a mole of donuts, we could have a mole of elephants, or let's look at chemistry, we could have a mole of, if I'm talking about elements, I'm talking about a mole of atoms. If I'm talking about ionic compounds, we count formula units. A mole of covalent compounds, well, that would be molecules. All right, our 7 diatomic molecules. So you can remember this in a couple different ways. Brinkelhoff is one way that a lot of people remember it. You can remember the 771. However you remember it, it's up to you. But it's going to be H2, N2, O2, F2, Cl2, Br2, I2. All right, define empirical formula. That's going to be the lowest whole number ratio of a compound. All right, let's look at find the molar mass. So in order to find the molar mass, the first thing you must find is the formula. So let's find the formula for magnesium chloride. Let's do that first. That's Mg. I look on the periodic table. Magnesium is going to have a +2 charge. I'm going to have chloride, that's Cl. Look on the periodic table, it's going to have a -1 charge. I crisscross. The formula is MgCl2. So I'll look on the periodic table. Mg's molar mass is 24.30. There's only one of those. Cl, I've got 2 of those. So the mass of the Cl2 is 70.90. All right, I'm going to add those two together. 0, 2, 1, 95.20. This is 95.20 grams per mole. All right, I'm going to skip the next one. You guys can figure that out. But let's look at sodium nitrate. Okay. And we can do the same thing. I've got 1 sodium. Okay. I've got 1 nitrogen. And I've got 3 oxygen. So 22.99, 14.01, and 48. Okay. It's going to come out to a nice, clean, even number. 85.00 grams per mole. All right. Let's go ahead and start looking at, so this is background. This is all stuff that we've talked about before. We've talked about diatomics before. We know Avogadro's number. You should know how to do molar mass. We did that. Let's go ahead and do some conversions, though. We're going to use our dimensional analysis skills. How many grams are in 0.682 moles of lithium? So remember, if I see grams, that means I'm going to have to come up with a molar mass first. Now in this case, it's easy. It's lithium. So I'll look on the periodic table, and lithium's molar mass is 6.94 grams per mole. And that's true for lithium. All right. I'm going to start out with 0.682 moles of lithium, and 1 mole of lithium has a mass of 6.94 grams. Okay? I'm going to cancel out my moles, and remember, this is true only for lithium. So you want to definitely write number, unit, stuff. See, number, unit, stuff on everything. And that's one way to make sure you know what you're doing. And so I take my little calculator out, and I want to do 0.682 times 6.94, and that equals 4.733308. Now let's look at our sig figs. I have 1, 2, 3 sig figs. I've got my 3 sig figs there. So my answer should have 1, 2, 3 sig figs. So my final answer is 4.73 grams of lithium. All right. If I were to do these other ones, I can do the same thing. I can go from molecules to moles. Now in this case there's no grams. Why is that? That means I don't need to calculate molar mass. So 0.347 moles and 1 mole of SO3 is going to have 6.02 times 10 to the 23rd molecules of SO3. And remember, you want to write out molecules. I know it's a lot to write, but you don't want to get yourself confused between moles and molecules. So that's how we write moles, that's how we abbreviate it. Write out molecules. You're not going to see it very often. It's worth writing out. And again, I'm going to take my little handy dandy calculator here, and we're going to type 0.347 times 6.02. Actually, let's go ahead and practice some good work here. 6.02 times 10 to the 23rd, close parentheses. This is going to be, my calculator is going to say 2.08894 times 10 to the 23rd. All right, seems reasonable enough. Now let's look at our sig figs. I've got 3 sig figs, so I'm going to go 1, 2, 3 sig figs. 2.09 times 10 to the 23rd molecules SO3. All right, and look at the next one here. These get into some of the multi-step things. And so let's see, let's pick one here. How many grams are there in 2 liters of CO2? All right, so remember, in 1 mole is 22.4 liters. And you're going to assume this is at STP until we tell you otherwise. And that probably won't happen until after spring break. So just be aware of that. So notice again, I have grams. That tells me I need to calculate the molar mass of CO2. You guys know how to do that. CO2 equals, so that's oxygen, 2 oxygens, which is 32, and 1 carbon, which is 12.01. So 32 plus 12.01 is 44.01 grams per mole. And if you forget how to do that, you can rewind the video and watch stuff from the front page. Okay. So in 1 mole, I'm going to go 2.0 liters of CO2. Right? That's going to be 22.4 liters and 1 mole of CO2. Now that gets me to moles, right? Because I'm going to cancel out liters here. But I need to go to grams. And so the next thing I'm going to do is put 44.01 grams and 1 mole. That's going to get rid of that and that. And so I'm going to actually multiply 2 times 44, it's going to get you 88, and I get a little 0.01 here, and divide by 22. So my number should be somewhere around 8 grams. So I'm going to do my little approximation here, and now I'm going to actually pull up my calculator. We'll do the punchy and see how close we are. So 2 times 44.01 equals, divided by 22.4, and that is 4. You see, this is why we use a calculator, right? So it's 4. 3.929, yes, because 88, right, divided by 22 should have been 4. All right. 92946 grams, and let's look here. I've got 1, 2 sig figs, so 3.9 grams of CO2. All right? That's the kind of, sometimes you need to take multi-steps here. All right? Percent composition, let's go over percent composition real quickly. Percent composition, sulfuric acid, H2SO4. I've got 2 of those at 1.008, it's 2.016. S, I've got 1 of those at 32.00, and then O, I got 4 of those at 16. I think that is 64. And so that's 0.01, 32. It's not 32, it's 3206, I think. Let's see, look, yep, 3206. So I've got to be sure and put that there, 3206. So let's see, that is 7, 6, let's actually use our calculators here. Let's do this, 8 and 9. Let's try and see if that's correct. 2.016 plus 32.06 plus 32, 6, oh yeah, I didn't line things up right. Oh yeah, no, there we go. Let's clear and start over again. 2.016 plus 32.06 plus 64. There we go, 98.076. So now I'm going to take this mass, 2.016 divided by 98.076. Okay, that's my hydrogen. Sulfur is 32.06 divided by 98.076. Okay, that's sulfur. And oxygen is 64 divided by 98.076. All right, so let's go ahead and do this. 2.016 divided by 98.076 is, well, times 100 for you. So that's 2.06. Remember, just go ahead for percent composition and give me 2 digits after the decimal. 32.06 divided by 98.076. And if you want times 100, so this is 32.69. And 64 divided by 98.076 times 100 is 65.26. And you add those up, it's going to get reasonably close to 100. So we can actually do that if you want to. So 2.06 plus 32.69 plus 65.26, and that equals 100.01, and that's just a rounding error. That's totally acceptable. All right. Finally, let's do an empirical formula. This one kind of scared a lot of people just because it kind of came out to be something strange. But we already have grams. So if you remember, this is our percent to mass, mass to mole, divide by smallest, multiply till whole. Okay? So we're going to do this right here. 5.9 grams of hydrogen. Remember, I've already been given the grams, so I don't need to do anything there. And 94.1 grams of oxygen. The molar mass of hydrogen is 1.008, and oxygen is 16.00. So the question here, this is grams per mole. You want to have those units there. So I'm going to say 5.9 divided by 1.008 equals 5.8532. Okay? And that's moles of hydrogen. And then 94.1 divided by 16 is 5.88. 125 moles of oxygen. Don't do much rounding here. You want a minimum of 3 digits on this step. 4 is even better. So don't round here, okay? Divide by smallest. Now the smallest one is this one. All right, this is my smallest. If I divide both of them by smallest, I end up with 1 mole of hydrogen and 1 mole of oxygen. So the empirical formula the lowest whole number ratio in this situation, you can write it as HO. No, that's not a compound all by itself, but that is the empirical formula. So the next question asks, how do I get to the molecular formula if its molar mass is 204.0 grams? Well, I'm going to do that by figuring out the molar mass of this. And that's 16, and that's 1.008, so that's 17.008. Is that right? I think so. Grams per mole. I'm taking this number, 204, divided by 17.008, and that looks like, so let me go ahead and write this out for you. 204 divided by 17.008 equals 11.99, which is really close to 12. So what that means is I'm going to take this number, this formula, and multiply it by 12, HO. That means my answer is H12O12. So that's my answer. All right, and I'm going to stop there. And if you have any additional questions, feel free to ask.